Hi all. Today we'll be discussing LeetCode problem of the day, prime number of set bits in binary representation. So here you're given a range of numbers from left to right. You just have to return the count of numbers that have a prime number of set bits in their binary representation. So in a binary representation, suppose you have the number 5. So set bit denotes how many ones are there in the binary representation. So, for example, if you have 27, 27 in binary is 11011, and this has 4 set bits. And since 4 is not a prime number, you won't count this number 27. And suppose you take the example 10 power 6. So this has total 7 set bits in its binary representation. And since the number of set bits is a prime number, this will be counted to our answer. So now let's look at the examples. So the first input is from range 6 to 10. So you have to check all the numbers from 6 to 10, which has prime number of set bits. So first, if we see for 6, it has 2 set bits. And since 2 is a prime, you count it. Next for 7, it has 3 set bits and 3 is also a prime. So you count 7 as well. Next for 8, it has only 1 set bit and 1 is not a prime number. So you don't count 8. Same for 9 and 10, it has 2 set bits. So both are prime numbers. So in the range from 6 to 10, your answer will be only 4. Now coming to the second example. Now the range is from 10 to 15. So again, for 10, you have 2 set bits, which is a prime. And for 11, 3 is a prime. For 12, 2 is a prime. 13, 3 prime. 14 also 3 is a prime. But for 15, it has 4 set bits. And since 4 is not a prime, you won't count it. So overall, in this range, there are 5 numbers which has prime number of set bits. So the answer is 5. Now coming to the constraints, the left and right can be from 1 to 10 power 6, and the difference of right minus left will be from 0 to 10 power 4. Now let's go the approach. So to solve this problem, you just have to iterate from left to right, iterate on all the numbers in this range. And for each number, first you have to count the number of set bits in the number. So suppose our number is 10. This is the binary representation of 10. So to count number of set bits in this number, so first we take this number and 1. So when you take the current number and do an AND operation with a 1, so you can see the last bit is 0, so the output will be 0. So that is how we check whether the last bit is set bit or not set bit. So we have a 0, so you won't count our answer. After this, you will divide the 10 by 2. So when you divide 10 by 2, it becomes 5. So this is the representation of 5 in binary. So that means when you divide by 2, the last digit disappears. So now for this number, again, you will take an AND operation with 1. Now, in this case, the result is not 0. The result is 1. So you'll add this 1 in your answer, bit count. So initially, bits are 0. So now bit is 1. So you have counted this bit. Next, you will divide by 2. That means this bit gets lost. So your answer will now become 2. So 5 by 2 will become 2. So again, for this, you'll take an AND with 1 and the result will be 0. So this bit is not set. Finally, you will divide it again by 2. So 2 by 2 will become 1 and 1 will be 1. And since you found a 1, that means this bit is set. So you'll increase your bit count. After this, again, you'll divide it by 2. So 1 by 2 will become 0. So once the number reaches 0, your process stops. So this is how you count how many set bits a particular number has. So in this example, the bit count is 2. And once you get the bit count, you just have to check whether the current number is a prime or not. Suppose you have the bit count as 11. So to check if 11 is a prime or not, we can simply iterate on all the factors of 11. And if the total, the count of factors is equal to 2, then it's a prime number. And if it's greater than 2, then it's not a prime number. So we can make a small optimization with the prime numbers, because for each number, we don't need to manually find whether it's a prime number or not. So first, let's look at the range of the numbers. So according to the constraints, the range is from 1 to 10 power 6. So 1 in binary is 1, and 10 power 6 in binary is this number. So the largest number in our constraints, its binary representation contains only 20 bits. So that means at max, the count of bits can be 20. So in our code, we can see we don't need to know any prime number which is greater than 20. So we just have to keep a track of all the prime numbers which is less than 20. So let's just note them down first. So 2, 3, 5, 7, 11, 13, 17, and 19. So these are all the prime numbers from 1 to 20. So whenever you have a number and you found the bit count, suppose for this example, the bit count is 7. So to check whether this particular number is a prime or not, you will simply verify whether this number is already present in this list or not. So this prevents duplicate calculations to find prime number for each number. Now let's quickly code the approach. So first, let me take a set to store all the prime numbers. Equal to 2, 3, 5, 7, 11, 13, 17, and 19. So these are all the prime numbers which is less than 20. And let's also take a variable to count the answer and just iterate from left to right. Left. So now we have to find for this number I how many bits, how many set bits are there. So let's take bits equal to 0 and also number variable to store the I. So just like we discussed how to find number of set bits in the number. So as long as number is not equal to 0, we check if number and 1 is not equal to 0, then bits plus plus. That means this bit is set. After that, we need to check the other bits. So we divide the number by 2. Equal to num by 2. And once this while loop is done, you found how many bits are set for this number. So now you need to know whether this value is a prime or not. So if set, if prime contains number, then you'll increase your answer. And at the end, return answer. Okay, I need to add a brackets for this. Okay, that's the issue. So here we need to check if the bits is a prime number or not the number. So I'll just make it bits. Yeah, let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So coming to the time complexity, here we are just iterating on the range. So we can say this is order of n. And inside that, we are running a while loop, and this will run this while loop will run log n times because we are dividing the number by 2 each times. So the total complexity will be order of n log n. And for the space complexity, we have declared a set, but it occupies constant space, and the space is not dependent on the input. So the space will be constant, which is order of 1. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.